and the first fundamental theorem of calculus. Okay, so hopefully that makes sense for number one. Now, of course, what's going to happen is you're going to come up with some other functions that are going to be much, much more complicated. And example number two is going to be one such case. If we take a look at example number two now, how are we going to find the area? Okay. Now, if we go ahead and take a look at the area that is bounded between the two curves, if we were to go ahead and just dot those, and I'm going to use black here so we can see. If I was to go ahead and dot it, this is the area that I'm looking for, because this is area that is contained or bounded by the blue and the green curve. Okay? There's no other area that's actually bounded between those two curves that is actually going to be finite. So if I was to go ahead then and to take a look at these two parts here, what I really need now, I need two integrals. Now, why do I need two integrals? The reason why is because things change because of the way that the functions are actually interacting with each other. Now, just like in this case up here, I'm going to draw the rectangle. Okay, so watch what happens. If I draw a rectangle to actually establish the height of the rectangle, okay, the height. So let me go ahead and do this over here, and do that over there. Okay. Now notice that the height of this rectangle right here is going to be established by the top function minus the bottom function. The top function in this case over here is actually going to be the blue function. The bottom function is actually going to be the green function. Notice what happens when I get over here though, is that they switch. It's now the green function that is the top function and the blue function that is the bottom function. So what that means then is that I'm actually going to have two different integrals. Okay, so let's go ahead and call these different areas then let's label them different. So let's just call this area sub 1 and this area sub 2. So what I know then is that the area, which I have here, is going to be the area sub 1 plus the area sub 2. Okay, so now what is the area sub 1? If I go ahead and take a look at the area sub 1, what are the limits of integration for that particular part? Now, if I go ahead and move this, notice that the values of the intersection point right over here are going to actually establish what your lower bounds and your upper bounds are for this particular segment, this particular area here. So I know that the x value is actually from 0, from x is equal to 0 to x is equal to 2. Okay, of the top function. Now which one is the top function? The top function is actually f of x. So that's f of x minus g of x, d of x. Okay, now of course if this were a particular function you would just substitute the particular function in there. Plus, okay, the area sub 2. Now here's the area sub 2 here. Now the area sub 2 is actually going to be defined from 2 to 4. So notice that is the integral from 2 to 4. Let's put x equal to. X is equal to 2 to x is equal to 4. Okay. Now notice that the top function in this case is g of x, and the bottom function is actually f of x. So this is actually going to be equal to g of x minus f of x, g of x. Okay. Now, of course, again, remember that the problems that you're going to encounter, they're actually going to be particular values, particular functions that are going to be used. But it's going to be important, one, to look at what the graph looks like. You have to be able to see what the graph looks like in order to actually establish which area you're looking for. The second thing is you need to then go ahead, after you establish which area it is, go ahead and draw the rectangles in each one of the different segments of areas. And then you can go ahead and label each area as a sub 1, a sub 2, a sub 3, a sub 4, as many areas as you need. And then after that, you need to go ahead and write your definite integral by each one, using each one of these segments individually, and then evaluating those as definite integrals, and using a fundamental theorem of calculus. Okay? So what we're going to do is we're going to take a look at some of these other examples in class. But hopefully you get an idea conceptually of what's happening and how to actually go ahead and calculate area between two curves by, again, first drawing them, finding out what areas you're looking at, and you're looking for, and then also making sure you're drawing your rectangles and you're associating each one of those segments with a proper definite input. Okay, so we'll go ahead and take a look at how to do some of those again in class the next time that we meet. Okay, good luck. See you again. Bye-bye.